Hello, my fellow mathematician and scientist. Welcome to Calculus 2. We have been looking at integrals, and now we are looking at inverse trigonometric function integrals. How do we integrate inverse trigonometric function? So I'm going to give you 3 examples here to show you how you will do the integrals. We are going to consider tan inverse of x, sine inverse of x, and the sec inverse of x. The rest, the difference is just the sign which you make use. Now, to begin with, we are going to consider tan inverse of x, and this one can be integrated by use of integration by part. So we are going to we shall let here our u be equal to tan inverse of x. Then we are going to let our v be equal to this other part here, be equal to dx. So from there now, we get u prime will be equal to, you can check in my YouTube channel how to integrate tan inverse of x, or you can look in the table of integrals. But when you differentiate tan inverse of x, the result will be 1 divided by 1 plus x squared. So that is the result of the differential of tan inverse of x. Now here, this is our v prime. So what we do here now, we integrate both signs. When you integrate the differential of v with respect to x, you are going to get v. So v will be equal to, when you so here we integrating both signs. To integrate that both signs, when you integrate dx, you will get x. Then from there now, what we are going to do, we are going to substitute in this formula. So you have integral of tan inverse of x, that is u, as you can see here. V prime is dx. This is equal to, our u is tan inverse of x. Our v is x. So you can write even x is there, minus integral of, now our v is x divided by our u prime is 1 over x. So here you will have 1 plus x squared. Of course, this is dx. So at this level, so we consider this part here. This part here will be integrated by u substitution. Now, for the tutorial on how to integrate by u substitution, you can check in my YouTube channel. But here we are going to let our u to be equal to this part here, the denominator, which is 1 plus x squared. Then you get your du will be equal to, you differentiate this. So 1 differentiated is 0. 2 differentiated will give you 2x dx. So our du over 2 will be equal to x dx, meaning that integral of x over 1 plus x squared dx is equal to half integral. Instead of x dx, we will write du divided by, instead of 1 plus x squared, we will write u. This is equal to, now on how to integrate 1 over u, you can check in my YouTube channel. I have done it for you, and you are going to get your answer. So the result will be half natural logarithm of, so the integral of 1 over u is natural logarithm of u plus constant c. Now here our u is 1 plus x squared. So now we come back here and substitute our result. So integral of tan inverse of x dx will be given by, we had found the first part here, it will be given by x multiplied by tan inverse of x minus, we are from here, following from here, this part here, there we have found it to be half, natural logarithm of modulus of 1 plus x squared modulus, then plus constant c. So that is how you integrate this part here using integration by part. That is how you obtain the value of tan inverse of x dx using integration by part. The result is this one. So the other part which is related to that is that of the cot. Hello my fellow mathematician, welcome to Calculus 2, and we are looking at integrals of inverse trigonometric function. In today's video, we will be focusing on how to integrate cos inverse of x, and we are going to see that the result is cos inverse of x multiplied by x minus square root of 1 minus x squared plus a constant c. We are going to make use of what is called integration by part, whereby you have function u. Our function u is cos inverse of x, and our function v prime is dx, which is equal to u multiplied by v. Our v is x, this one, and our u is cos inverse of x minus, so we are going to see now how minus integral of u prime is this one here, then multiplied by v. So to begin with, we are going to write cos inverse of x dx. So cos inverse of x multiplied by dx is equal to our v is x, is equal to x multiplied by, now our u is cos inverse of x multiplied by cos inverse of x multiplied by cos inverse of x minus integral of our v prime is dx minus our v is x minus x dx divided by our u prime is this one. Now cos when you differentiate cos inverse of x, we will get -1 divided by square root of 1 minus x squared. Now to know how we arrive with the u prime being equal to -1 over square root of 1 minus x squared, you can check in my YouTube channel at Look Aaron 1, and you are going to see how we obtain that value in a simple method step, and we are going to see. So this is a square root of 1 minus x squared. This one there, x squared. Now v prime is dx. So how are we obtaining x here? Integral of v prime is v, integral of dx is x here, taking integral both sides. Integral of v prime will give you v, and the integral of x will give you x. So the focus now is to integrate this part here. Remember, when you are substituting, to include this negative here, there is that negative there. So we want to integrate this part x dx square root divided by square root of 1 minus x squared. So this part here will be done by we are going to let our u to be equal to the denominator, what is inside the square root of the denominator, which is 1 minus x squared. Then we differentiate, du will be equal to negative. When you differentiate x squared, it will give you -2x dx. Then from there, you divide both sides by -2. So du divided by -2 will give you, you will be left with the x dx. Then you come here and you substitute. Instead of x dx, you are going to write -1 over 2 du divided by, instead of 1 minus x squared, you are going to write u, and because it is square root, power half is the same as square root. Using the laws of indices, you can take u up. When you take u up, the index will be -half du. So this is -half du. Now integrating by power rule, what you are going to do, we are going to add 1. So you have, we can do it aside here. You have power -half plus 1. This is the same as u power -1 over 1 plus LCM is 2. So 2 divided by 2 is 1. 1 times -1 will give you -1. 2 divided by 1 here, it will give you 2. 2 times 1, sorry, will give you 2. So -1 plus 2 is 1 over 2. So the result here will be half multiplied by 2 over 1 u power half plus constant c. Remember, there is this negative outside. There is negative. This is equal to, this one will cancel, and you will have negative u power half plus c, which can be written as negative integral of, our u was 1 minus x squared plus constant c. So now meaning that integral of x dx over 1 minus x squared is the same as negative integral of 1 minus x squared plus constant c. Now remember, our objective was to integrate cos inverse of x. So this is the part we have found there. So the final result will be, so we are going to combine this part and this other part here. So integral of cos inverse of x dx will be given by x here, this one, x cos inverse of x minus square root of this other part here which we have found, minus square root of 1 minus x squared plus constant c. So to do this, it appears to be a bit lengthy, but provided you know how to integrate by part and you have knowledge of calculus 1, which is differential calculus, that when you differentiate cos inverse of x, the result is negative 1 divided by square root of 1 minus x, and you know how to integrate simple integrals, then it becomes simple. And also, it is testing the knowledge of integration by use of substitution. Now, this symbol here, minus and minus, will be positive. So that is why now, when we come to the final result here, we have this part here being negative, because when we integrate x dx over square root of 1 minus x squared, it is giving us negative of 1 minus x squared, as shown here. So thanks so much for taking time to study with me calculus 2, and particularly on integration of inverse trigonometric function. For other integrals of inverse trigonometric function, you can check in my YouTube channel, and you are going to obtain the result in a simple step method. Thanks, bye bye, see you in the next video. Remember to like and also to subscribe to this channel and to share with other mathematicians so that we may continue learning together. Hello my fellow mathematicians, welcome to calculus 2. We are concentrating on integrals of inverse trigonometric function, and in today's focus it is how to integrate sine inverse of x dx, and the result is x sine of x plus square root of 1 minus x squared plus a constant c. Now to do this, we are going to apply integration by part. We are going integration by part. U is this function here, sine inverse of x, and our v is dx. Now on how to use integration by part, I have already done a video tutorial. You can check it out, but for here we are only going to make use of it. So to do that, we let our u to be sine inverse of x dx, as shown here. Then we differentiate sine inverse of x. On how to differentiate sine inverse of x, I have already done it in my YouTube channel at Look Aaron 1. You can check out and you are going to see the process. But at calculus 2, what you need to be aware of is the result. So sine inverse of x is given by 1 divided by square root of 1 minus x squared. Then v prime, the one we are writing it to be our v prime, is dx. Then we integrate in both signs here. You integrate in both signs. When you integrate v prime, you will get v. When you integrate in dx, you will get dx. Then from there now, you come and substitute. Your values. In this formula. Our u is 1 over square root of our u is sine inverse of x, sorry, our v is x. So you write your x there. Our v is x, then our u is sine inverse. sine inverse of x, then minus integral of, the formula gives you v prime, u prime is 1 over square root of 1 minus x. V is x, so here you write your x divided by square root of 1 minus x squared dx. Remember that it's just dx that way. So what we are going to do now in the next part, we are going to integrate this part here. So you have x divided by 1 minus x squared square root. So we want to integrate this bit, and we are going to integrate it by what this is dx by what is called u substitution. So we are going to we are going to integrate this part by letting our u to be equal to 1 minus x squared. Our u prime will be equal to, when you differentiate this one, you are going to get you shall get negative 2x dx. You can divide both sides by negative 2x to get 1 over 2 du, which is equal to x dx. Then we come and substitute our result here. Integral of x dx divided by square root of 1 minus x squared is equal to negative half integral of, instead of x dx is du. This negative half is outside. Du divided by u. This is square root, which is the same as power half. Using the laws of indices, we are going to have negative half integral of, u can come up to be negative half. Then we integrate this, so the result will be negative 1 over 2 multiplied by 2 over 1 u power half plus constant c. What I've done here is very simple. You have u power negative half. Integration says u and u1. This is the same as u power negative half plus 2 over 2 when we add 1, which will give you u power half negative 1. Negative 1 plus 2 is 1 over 2. So we divide by reciprocal by half. So when we divide by half here, it is the same as 2 times that. So that is what we are going to obtain there. Meaning that now integral of this part here, there is a negative here. So 2 and 2 will cancel, so you will have negative of u power half plus constant c, which is equal to negative square root of, then we substitute back, our u is 1 minus x squared plus constant c. Then we come back and substitute the other value. Remember, we were here. This is where we were. We were looking at the integration of sine inverse of x and sine inverse of x. Of course, here you have dx. We had found one of our result as we had found it to be x. You have x there, sorry. to be x sine inverse of x. Now the other part here, check the formula by integration by part. This is minus, and there is another negative here. So minus and minus will become positive. So plus square root of 1 minus x squared plus constant c. Now actually we have arrived where we were going, because we are supposed to show that sine inverse of x dx is equal to x sine inverse of x plus square root of 1 minus x squared. So that is how you do it, using integration by part, and also applying the u substitution through step-by-step method, and you obtain your answer easily. So for the other part on integration, you can check in my YouTube channel at Luke Aaron 1. I have already done, and you are going to get learning, and you are going to get the knowledge. Hello my fellow mathematician and other scientists. In this video tutorial, you want to see how we integrate the inverse trigonometric function. And today we are considering how do we get the integral of cot inverse of x dx. Actually, we are supposed to prove that the result here is equal to x cot inverse of x plus half natural logarithm of 1 plus x squared plus c. So that is the result. So we are going to use integration by part, which tells us we are letting our u to be cot inverse of x, and we are letting our v prime to be dx is equal to u u multiplied by v which is minus integral of u prime. So here our business is to get u prime. If you can check in my YouTube channel, I have shown you how to differentiate cot inverse of x. So the result here, I will give you the result is negative 1 plus x squared. So we have got our u prime. Then here, to get our v, we are going to integrate this both sides. So the integral of v prime differentiated will give you v. And when you, of course, there is dx here. And when you integrate and differentiate x, the result will be x. So that is what we have. We are going to substitute in this formula. So integral, instead of u, we are going to write cot inverse of x multiplied by our v prime. Our v prime is dx is equal to our u is this one, and our v is that. So we have this is equal to x multiplied by our u is cot inverse of x. So you have cot inverse of x. Cot inverse of x. Then you have minus integral of our v prime is, our v is x. Our u prime is negative 1. So you have negative 1 dx divided by 1 plus x squared. Now this part here, let us now consider the last part here, this one. Negative and negative will come together to become positive. So you have d x dx divided by 1 plus x squared. So to integrate this, we are going to use what is called use substitution. Again, you can check in my YouTube channel. I have shown you on how to integrate using U substitution, and you are going to get your result. So here we are going to let our U to be equal to the denominator, which is 1 plus x squared. Then we are going to differentiate both sides. Du will be equal to 2x dx. We divide by 2 both sides to get half du, which is equal to x dx. Once you have that, now we come here and substitute. We have integral of x dx divided by 1 plus x squared. This is equal to half. That is equal to half integral. This half is this one here. Instead of x dx, we substitute it with the du. Du divided by, instead of 1 plus x squared, we substitute it with u. Now, on how to integrate the 1 over u, you can check in my YouTube channel at Luke Aaron, and you are going to get your result. This is half natural logarithm of modulus plus constant. Natural of u plus constant c. We now substitute. We have half natural logarithm of our u. You substitute back. Our u is 1 plus x squared. 1 plus x squared plus constant c. Then now we come back. So we are having integral of cot inverse of x dx, which is equal to half. Here we had obtained x cot inverse of x. Now this here, now this part here, minus and minus will give you plus, so plus this part which we have obtained here, half natural logarithm of modulus of 1 plus x squared modulus plus constant x. So that is how you obtain there is x here, sorry, this x here, up here, x cot inverse of x. So that is how you obtain the integral of cot inverse of x. For the integral of tan inverse of x, you can check in my YouTube channel. I have done it, and you are going to get your result. So this question required you to show that cot inverse of x dx is equal to x cot inverse of x plus half natural logarithm of 1 plus x squared plus constant c, as we have done down there. So the secret is knowing how to integrate by part, and also having the prerequisite knowledge of differential calculus or differentiation, whereby when you differentiate cot inverse of x is equal to negative dx negative 1 and divided by 1 plus x squared. This is du over dx, so when you multiply, you will have this. Alright, then when you integrate v prime, it will give you v. When you integrate dx, it will give you dx. Then you substitute. This the other part here. Now you apply integration by u substitution, and through that now you get your answer in this simple step methods. So thanks so much for taking time to study this part here. For the others, stay tuned in my YouTube channel. For the other integral of the inverse trigonometric function, stay tuned in my YouTube channel at Luke Aaron 1, and you are going to see how they are done. It's a simple step method. If you have not subscribed, also remember to subscribe to this channel so that you get notification every day when I post this teaching.